Hi there, we're back again. This time we're going to look at our guru and learn how to find the least squares regression line using our guru. Sometimes this line is called the line of best fit. So the first thing we need is some data. So I'm going to click under my data tab here on the left. And prior to this video, I typed in some data that is directly from your Hawks textbook in your Learn section. It's table 5.2.2. You can see here it's 14 rows, which corresponds to 14 different Honda Civics and the age of which they are, and also their asking price here for selling a used car. All right, so again, 14 Honda Civics. And again, we get two pieces of information on them. This is bivariate data. We get the age of the car and then what they're asking for when they sell it. All right, so we want to see if there is a linear trend. Actually, there is a linear trend, but we're going to go straight to finding that least squares regression line or equation. And you can do that by going to analytics. So under analytics, I'm then going to go to the further drop down box that gives me options, tons of options here. We're going to hit most of these this semester. We're going to linear regression here. And then even deeper down, you can see it's simple regression. That's the one we're using in our stat course. When that comes up, I get the traditional pop-up box. I need to communicate with our guru what's going on. So I have to tell it the data set in particular I'm using. So even though I clicked on that data set and it was sitting in the spreadsheet for us to view, I still have to nudge our guru and tell it to use table 5.2.2. Now, once I tell it to use table 5.2.2, it then knows the variables that are present in that data set. So our predictor variable is going to be age, or you could call that the explanatory variable. And our response variable, our Y variable here, is going to be the asking price for the car. And that's all I need to do to get the least squares regression line. Now, there's a lot of other options here we can talk about in a later video, or your teacher might talk with you about those. But for right now, I just want StatCrunch to go through that tedious process of finding the line of best fit. So we'll click on the eyeball, the preview here to see the results. And right here in this top portion, we get a summary of what they did. It repeats back how many rows we worked with. It was 14. It gives us R. This is another place where you can get the Pearson correlation coefficient. R, it's right there at negative 0.95. So a very strong negative linear correlation. And also the last one is equation of least squares line. Here it is. Got it right here. They give it to you. It seems a little wonky. It doesn't have X's and Y's in it because we gave our variables names. So these names are showing up in the equation. And I'm about to switch over and talk a little bit more about this equation. As I scroll down a little bit, I'll scroll down just a bit. You can then see the least squares line here directly superimposed on top of the scatter plot. So you can see that that line does a really good job of summarizing this relationship between the two. And we can use it for all different kinds of purposes. But there it is, along with our 14 cars that correspond to these 14 dots. It's a little tricky to see how many dots are there right now because they're kind of close together, but we can now see them. All right. So we have this line. I just wanted to put it on something that's a little bigger where I can talk a little bit. And we have asking price there. That's our Y variable, our response variable, equals 19,198.32. I rounded to two decimal places since we're talking about money, minus 14,000, or not 14,000, 1,412 and 23 cents times age. Age is our explanatory variable, our X variable. So what are these values? Well, this first one given is the y-intercept. So when you get stuff out of statistical software, they always lead with the y-intercept, unlike algebra class. So this number here is the y-intercept, and the second number is the slope, the 1,412 and 23 cents. That's our slope. So it has the traditional y-intercept and slope that linear equations have. It has our y variable asking price and our x variable age. So again, just to recap, in a traditional algebra class, the coefficient, the multiplier on our explanatory variable or our x variable is our slope as well. They've just reversed the order on us in this output. Hope this was helpful. Stay tuned for more videos.